Okay, we're going to do a short one tonight, but, oh, and no coding. Or at least I don't plan to do any coding. I guess we'll see what happens. But mostly I wanted to have tonight be a small footsteps moment. That very busy day, lots going on. But part of my goal with this channel is to share some of the things that I feel like I've learned, at least this far along in my journey. And one of those things is that small footsteps every day do incredible things for you. And it's not just the accomplishments, the things that you actually do. It's something about the way it rewires your brain that you start to get an increased level of confidence, I think, in yourself and your ability to achieve things because you're building up more and more data that substantiates that belief. And so there's a cognitive rewiring that appears to happen, or at least this is what I think has happened with me. You don't need to climb Mount Everest every single day, but I think that there is something that's quite important that happens if you demonstrate to yourself day in and day out that you can stay committed to something. And then the large problems, I think, start to get solved. On top of that, this never stop growing seems to coincide with a very brief thing that we'll show today, which is about getting support for all three types of the communication, which we see down here. This will be maybe another example of the importance of spoken, written, and visual communication. As far as the technical thingy, we're going to take a look briefly at Microsoft OneNote. And to be clear, any of the tech that I talk about on this channel, I am going to try my best to look at these things from a technical perspective, and I'm going to refrain from any sort of personal or political bias that some may or may not have toward the company or the entity of the thing that I'm describing technically. And I think that that's important because I think you can have things that end up having value, and they don't necessarily come from maybe your favorite people in the world, but I don't know that that necessarily devalues them, or at least maybe not completely. And as I think we discussed in one of the former podcasts, or maybe several, is I'm not a super fan of that company due to a number of data I have on things that they've done, either as money grabs or lack of effort, or just trying to stamp out competition, which is, in my mind, one of the most important forms of capitalism, and the reason why free markets, I think, have such tremendous value, that it's not in spite of the competition, it's because of the competition that you're able to have the best solutions, or the best companies, or the best talent, or whatever sort of rise to the top. Now again, this is nuanced. This is not the whole story. And there's going to be unfairness. Absolutely. There's unfairness, and there's various lotteries that people are winning based on where they're born, the genetic code that they get from their parents, things like legacy wealth, all sorts of things. And this is why I think it can't simply be this notion of just work really hard and you'll be able to succeed in anything that you want to. This is, I think, overly simplistic. It's, yeah, far more complicated than that. However, if you resign yourself to failure simply because other people were more gifted, they won the genetic lottery, they had the right parents, they have an incredible amount of wealth or access, all those things, and then you decide that you can't achieve greatness because you weren't gifted those things, I can pretty much guarantee you that if that's the mindset that you have, you probably never will achieve greatness. And just because you set your mind to it and you work at it over and over, it also does not mean that you will achieve it. But I think that that is why we focus on meaningfulness and not happiness. When you strive every day to live a life of meaning, you become, at least in my mind, more journey-oriented. You are journey-driven rather than outcome-driven. And you may still have a goal in mind, things that you want to achieve, but the biggest reward is not actually getting to the destination. It's the daily battles that you're fighting, and winning or losing every single day, the outcome of those battles, in some ways, is less important than the battles themselves. And again, if all the battles that you go through are all wins, you probably, at least in my mind, are not pushing yourself hard enough. It's time for you to level up, so to speak, and to lean into my role-playing game background. It's time for you to find a new zone and fight some tougher monsters and lose a few times so you can figure new strategies out. You can find new weapons. You can get more experience, and those things are going to come a lot faster when you continue to level yourself up. And that, I think, coincides with this whole never stop growing, as I think we all know, to some degree, when maybe we've reached this point in our life where we're not growing like we used to. And I think, at least for me, that can be one of the most dangerous places to stay in. One, because it often is very comfortable. It also has the ironic feeling of being safe, when in fact I would argue that it's oftentimes the opposite of safe, purely because of the comfort, because of the lack of growth, is that you have this overwhelming sense of, or can have this overwhelming sense of security, because you have this thing figured out. You've done all the right steps to get you where you are, and so can't you just kind of chill out a little bit and stop pushing so hard? You know, is there no end to your ambition, as people will often ask me? And what I'll tell them is the goals that I seek are not in the outcomes. The goals that I seek to achieve is in the effort to move toward those goals. And as we discussed in one of the former podcasts, it's actually my hope that many of the things that I'm trying to solve now, I can't solve, because then I have to come up with new, harder problems, And anybody that knows me knows I have no quit. Like, the day that I stop working is the day that I'm dead. Because I love the work. I've learned to embrace the discomfort, the pain. And I do think that there's some overwhelming sense of satisfaction when you consistently push yourself and try to become the best version of yourself. You're no longer competing with who people that historically may have been your heroes, or they have more beans than you have. Beans being wealth, publications, education, experience, partners, friends, whatever these beans could be. And mostly I think that any kind of general bean counter system, when done in isolation, is usually a very bad metric to follow. I think we should have these things that can help us in terms of maybe ballparking where we are compared to maybe where we were before. But ultimately, I think the more important metric is not in the quantity of things, but it's in the quality of things. And this is why I tend to care more about competing with myself rather than other people, because I know all the details about my own life. And I know when I'm making forward progress in my life and actually growing. Whereas with other people, I don't know their story. I could be massively advantaged or disadvantaged against them, and therefore it could be extremely hard, it could be extremely easy. But with myself, I know my story. I know the things that I'm weak on, and so I can have an outstanding day, and other people may look at it as I've just had a miserable amount of failures, but I know where my weaknesses are, and let's say perhaps I grew in this day in a way that other people are not aware. That could be a massively meaningful day for me. On the other hand, I could be doing things that other people may think are sort of like wild successes, because perhaps in their mind it's something that feels very impressive. But for me, it's not really impressive because I didn't actually grow. And so a concrete example of this is Taylor and I were at an event a few weeks ago, and there were some interesting things that happened in this event related to things that I was doing, as well as things related to the company. And after these things happened, there's many people at this event that congratulated me and said things like, "This was amazing, you're fantastic," so on and so forth. And while I appreciate the praise, I appreciate the feedback, in my heart of hearts, as I even mentioned to Taylor, I had no growth during these things that people were praising me for. There was no incredible accomplishment. It was actually something that is somewhat trivial for me. And so from other people's view, because this thing that they were referring to perhaps was something that they're not super versed in, they believed that it was a great accomplishment. But for me, it's not. And so I actually, after this event or these main things were going on, I actually then switched back into work mode, because I needed to actually get some small footsteps forward, and I needed to have some kind of meaningfulness. Like, again, yeah, it was pretty happy, to be honest. I think that even though I don't live in the world of needing external gratification or external confirmation, I think it's easy to feel happiness when other people are telling you how great you are. Likewise, it's also, I think, easy to feel sadness when other people are telling you how not great you are. And ideally, I think we want to kind of be somewhat neutral to both those things. I mean, neutral in the sense that we can appreciate what the person is saying, we can foster goodwill, we can thank them for taking the time to give us these compliments, but they shouldn't necessarily change our view of ourselves, especially if they're things that we know deeply are not things that we can improve in, or something that perhaps we've already mastered where they're congratulating us, or something that is not necessarily a character flaw or a weakness that we have that someone else is pointing out through a critique or a criticism. So yeah, I think that this is maybe an example of what I mean on this. We can compare ourselves to ourselves, and we're, I think, in many cases, the best qualified to understand when we're actually growing and when we're not, and to, sort of follow these principles, if we can, on a daily basis. The small footsteps, never stop growing, meaningfulness over happiness, deciding that you're world class, and proving it to yourself every day. And then this last, comparing yourself only to yourself. This world class part, I think, is quite interesting. And I think the second part about proving it and reproving it to yourself every day is extremely important. And the reason for this is having the mindset that you are good enough. This idea where you have confidence in yourself because you've made it this far. And sure, let's keep growing, but not to look at yourself as if you're a failure, not to look at yourself and have this overwhelming sense of inferiority compared to other people. Being honest is one thing. Being very antagonizing to yourself is a completely different thing. And while I think that it's really bad to congratulate yourself too much, it's also really bad to beat yourself up too much. That growing and becoming truly world class is something that will take time. But the part about deciding that you're world class is this notion that you will become world class as long as you have the mindset that you are and you put in the work. The tricky part is that when you're first brought into this world, I really don't think any of us are world class. It's something that you achieve through effort. But if you don't have the confidence in yourself to try, then you likely never will. And if you don't try, then there's basically a 0% chance that you'll ever become world class. So you can see how this is a bit of a chicken and an egg problem, but this is at least the way that I think about it. And what I try to do is I am accepting of sort of who I am today. I definitely want to be growing and becoming better, but I don't sit around and get in my head and tell myself about the bazillion things that are wrong with me. I know I have a bazillion things that are wrong with me, but I also have a few things that are not wrong with me. And the only way I'm going to be better at the bazillion things that are not right in me, the things that I'm weak on, is to go out and work on becoming better. So you have to put in the work. You've got to do the podcast at 1 a.m., whether you're tired or not. It doesn't matter, right? And in fact, some would argue, as we're going to see here shortly from this video, the days where you're the most tired, the days where you're the busiest, the days where you really don't want to do it, the days that you can get away with it and no one's going to know, those, I find, oftentimes are the days that it matters the most that you stay the course. Because something happens up here. There is some sort of mental rewiring. At least this is what my experience has been, is you literally start to condition yourself. You start to build mental endurance, mental toughness. And then it becomes easier and easier to power through because you've rewired things. You know you can do it. Whereas before you did it, before you push through on the days when you're super tired, maybe you didn't know. Maybe you actually didn't have the mental toughness. But just the act of going after it and putting in, oftentimes people will say, starting is half the battle. I absolutely agree that I was this close to not doing a podcast tonight, but I was like, you know what? I'm just going to do a short one. I won't do any code. And I love coding, but the problem with the coding is sometimes I'll go down the rabbit hole. And I actually started doing that. I was looking at Mentor and okay, I'm not going to write code, but let's just look at this for a second, not to send us on a total tangent, but just for a moment. This is an example, I think, of what happens if you're writing code and it's like being maintained iteratively, and it's not done in a smart way, in ways of like never nesting. And the thing that I find is really interesting about this code is, well, there's many things. And what this is PowerShell. So if you're on Windows and you're, if you're like a systems level developer, you probably are using PowerShell or have in some capacity. But what's curious to me about this control expression is the fact that it does this check to make sure that include is not equal to null. And then it subsequently checks to make sure include is not equal to null. But to make matters even more interesting, these two checks actually make sense because of the way short-circuited logic works. And so the person that wrote this code, it seems to me, is not misunderstanding. In fact, I think they are actually deeply understanding. What could happen is you could fail this first group of expressions, this first phrase, up until this logical or, and it could give a single false. And the moment you get a single false with a series of ands, it's false. That means this could have returned false before you ever check if include is equal to null. So it could, for example, fail without seeing include is not equal to null, which perhaps it is. Therefore, if you try to access include.count before checking it, this could actually create essentially a null pointer dereference. So having this checked twice makes sense for that very reason, that you do need to safeguard this. However, if you wrote this code in the way that I was showing in one of the former examples, where you search for all the bad cases first and you exit out, once those bad cases are essentially, those bad case checks are verified that you're in a acceptable state, you no longer need to check if include is null or exclude is null. And then what would happen is this check, and this check, they all go away. And then what you would end up with is that recurse and not this, and include .count is equal to 0. And if these things were equal to null, you would essentially not get to this case, and you would have some sort of exit strategy. Now, I haven't looked at this code deeply enough to see if this would actually work, but what I have noticed is that, I can kind of tell just by looking at this function that this code it could use some improvement. And part of the reason for that is just doing a quick assessment of the never nesting, which again, I think that looking at code that gives you a large degree of nesting is one of the fastest ways to determine if the code is sort of high quality or if it's not super high quality. Again, I encourage you to look at some of the best software that's out there in the world, things like Linux or Git, Kubernetes, what have you. And I think that you'll find that the nesting tends to be minimized. And a big part of that is to try to reduce the mental burden of understanding the code. And then when the mental burden for understanding the code is significantly reduced, then maintaining that code or expanding that code's feature set, fixing the bugs in that code becomes significantly easier. This function, for example, seems to have some nesting, some extra levels of nesting. So just to quickly get a sense, so this is the first level. So level 1, 2, 3, 4, 5, 5, 5, 6, 7, 8. No. I just, in general, no. This is sort of like never fly in code review with me. It's just, it's too many conditions. It's, I think, yeah, not in really high quality code. And so having something like this, again, is not super surprising of, having these redundant checks, which in the way that it's designed is necessary, but it doesn't mean that you have to design the software this way. If you design the software in a more elegant way with a little more thought up front on how to make the function or the code easier to understand, I think that you could probably get rid of. I've yet to see a case where there's a function that I can't bring down to, let's say, at most 2 levels of nesting. And it just has to do with the things that the Never Nester video talks about. The flipping the cases and then doing extraction. So anyway, what was my point with all of this? I'm not actually sure, but maybe we've done some growing. I'm trying to think if it was compare yourself only to yourself, and maybe that's the case here, is we're trying to show that this would be something where you could have something that works in code, and then you can go and refactor it and make it slightly better, small footsteps, this kind of thing. Okay, but I want us to watch a little bit of this video, and yeah, and keep in mind as you're watching this, these virtues. This also will touch on a little bit of the 3 forms of communication. Again, the 3 forms are, this is a spoken thing, written, or visual. And I've been doing some speaking. This channel will have some interesting stories, but there's also some interesting visuals that I think make the story much more relatable. And then we'll also look at some one additional piece with this Microsoft OneNote. Okay, so let's get started. This isn't going to go too long, but I quite like what this gentleman is saying, and I want to say that these types of things, what he's doing here, these are one of the key ways that I remain highly motivated, is I will watch things like this. I'll remind myself, like on the days that I'm tired, or the days where I feel like, wow, can I take a day off? And, certainly sometimes, that's exactly the right thing to do. But for me, one of the things that I try to do is to not negotiate with myself. If I know what the right thing to do is, try to do that right thing and not compromise or negotiate with myself in my head. Goju, you've done so many already. Can't you just take tonight off? Well, I made this promise that I was going to try to do this. Well, you're already ahead, and so you have this back and forth in your head. And then secretly, I think we all know kind of that the hard path is, in these cases, it's not always clear, but many of the cases, the hard path is the right path. But we're trying to kind of get out of it because we just want a little bit less pain. And I'm telling you, once you can really start to embrace the pain, really start to love the discomfort, I think it's just a game changer. Okay, let's hear what he's got. And I'm gonna mute myself somehow. How do I mute myself? Yeah, this is a new mic. Actually, I'm just gonna play it. Hopefully this won't give us the echo.
Look in the mirror. That's the only person standing between where you are and where you want to be. Not your boss, not your parents, not the people who doubted you, just you. Every single day, you wake up with a choice to push yourself, to get better, to move forward, or a choice to stay where you are, to make excuses, to let life pass you by. It's you against you. And the outcome, that's on you. Too many people waste time looking around, comparing themselves to others. They see someone else winning and start thinking, why not me? They get caught up in jealousy, in envy, in distractions. But here's the truth, none of that matters. Someone else's success doesn't take away from yours. Their progress doesn't slow you down. The only thing slowing you down is you. Your doubts, your fears, your unwillingness to put in the work. Success isn't about luck. It isn't about talent. It isn't about having the right connections. It's about discipline. It's about showing up every single day and putting in the work when nobody is watching. It's about holding yourself accountable when no one else will. Some people want to be great, but they don't want to sacrifice for it. They want to win, but they don't want to work. They talk about what they're going to do, but never actually do it. And then they wonder why nothing changes. If you want real change, you have to stop lying to yourself. You have to stop making excuses. You have to stop waiting for someone else to believe in you. You have to believe in you. You have to wake up every morning and remind yourself, I'm in control. I decide what happens next. I refuse to settle. I refuse to give up. I will outwork, outlast, and outgrow every version of myself that came before today. Nobody is going to come and save you.
I can't remember exactly what he said, but he said something like, I will outwork, I will out-sacrifice, I will whatever, all prior versions of you. The comparison is perpetually against yourself and only yourself. This is, I think, really the right mindset. And again, notice that much of this has more to do with the mindset, the world-class mindset, than any native talent that you may have been gifted or not gifted, because in some sense those things are completely out of your control. And therefore, focusing on just the things that we can control, this is the path to progress, in my opinion.
Nobody is going to do the work for you. Nobody is going to wake you up early, force you to put in the hours, or push you when you feel like quitting. That's your job. That's your responsibility. You will fail. You will fall short. You will have days when you don't feel like it. That's part of the process. But the people who succeed, they push through those days. They show up anyway. They do the work especially when they don't feel like it. Excuses sound great when you're making them. They give you comfort in the moment. But long term, they steal your future. They rob you of your potential. And before you know it, years go by, and you're still stuck in the same place, wondering what went wrong. The only way to win is to fight through the resistance. To silence the voice in your head telling you that you're not good enough, not smart enough, not strong enough. That voice is a liar. That voice is trying to keep you small. That voice is the old version of you, the version you're trying to leave behind. You have everything you need to succeed. It's already inside you. But you have to be willing to put in the work. You have to be willing to keep going, even when it's hard. You have to be willing to compete against yourself every single day. Because at the end of it all, when you look back on your life, the only question that will matter is this: did I become the best version of myself? No one else can answer that for you. It's up to you to decide. Your move. There is no shortcut, no easy way, no hack that will get you where you want to be without effort. The only way forward is through discipline, consistency, and a relentless commitment to being better than you were yesterday.
Excellent. So with that, maybe I'll put a link in the description. I stumbled across this tonight, and it actually quite it inspired me, and hopefully it's inspiring you. I also subbed this growth paradox. I really find that, again, just for me, that when I have these moments of, boy, I'm tired, just spending a few minutes listening to this stuff, as kind of silly as it may sound, this helps me significantly. It reminds me why I'm doing what I'm doing and how this really matters. And the reason why it really matters is it matters to me. That I want to do things in this life that are going to hopefully make things better in some small way. And as long as I'm working toward that on a daily basis, then I think I'm doing all the right things. So, yeah, definitely encourage all of you to watch this whole video. I've only watched the first 5 minutes myself, so hopefully the rest of it stays just as good. But I wanted to share one more thing before we end tonight, and that is on my pursuit of never stopping growth, constantly trying to make things better. One of the things I really needed is I need to be able to draw pictures in order to express some of these more complicated things when we get into advanced machine learning, machine programming, understanding how to reason about code semantics, and start to understand how to extract out intentionality or do intentionality sort of completion. And so tonight, or earlier today, I figured out at least one way to do this. And so moving forward, at least until I find something better, we now have a third piece that we can use to communicate, and that's through visuals. And the visuals I can do on my tablet here, and let's just see if so we'll call this step number 1, code. And we're going to just say that this is like some void function, and it's going to do something. And then this is going to be the first piece. The second piece, step number 2. And what's also great about this is any point, if I can, oh, it looks like it stopped working. But hold on, let's not lose faith. These are our don't race to the end, and complex things can require deep thought. And change this to view. No. Deep reasoning and in iteration. So let's try something here. And I've seen this a little bit with Microsoft. Okay, let's see that there. So what I'm trying to figure out now, I was able to do this before, where I could force this to sync. And so that is on that. It's just dropped the sync button from me, as it likes to do. But we're not that easily deterred. Let's see what we can find here. Sync on Wi-Fi only? No, that's what I want. Okay. So we're going to go back to this. And maybe switch to this guy. Okay, here we go. Sometimes OneNote just needs, yes. Fingers crossed. It says it's syncing in the background. I got a feeling that, come on, you can do it. I know you can do it. And I'm really trying to resist pressing any particular button, because if I do, I may have to edit the video in case I press the wrong button and I accidentally show some early stuff. Okay, sync, come on, you can do it. Oh, here, let's try this. We're going to try to switch the Wi-Fi network to a super Wi-Fi. Okay. We're now on the super, I think we're on the super Wi-Fi. Yep. Super Wi-Fi. Okay, we're going to try now. Sync. Come on, you can do it, buddy. We thought that this was going to be constantly iterating and growing. Still trying to sync in the background. I think that's not the answer. Okay, let me just close all this stuff. We're going to try this again. The good news is, for all of you, you can just, fascinating. You can just put this on a speed fast forward until it gets to the actual syncing. I think I may have to just edit this, which and not because I don't mind I'm trying to hide the failures. I'm all for the failures, but just to not waste all of your time. Huh. Account. Yeah, that's the right account. Okay. Step 2. Let's just see if I can. We'll call this let's extract. Extract intermediate representation, and then this will be some sort of, oh yeah, some thing like this. Okay, then this. Okay. Let's see. Okay. Exit that one more time. Wow. This is actually one of the reasons why I stopped using OneNote, actually, is okay. Home. Reason goes to TikTok. Share. Huh. There we go. What do you think? Are you gonna actually sync it? Here's what I actually think. I think that Microsoft's syncing servers or services have gone down, and so they have the ability to have the app work, but the syncing service has an outage. And again, I've seen some really wacky things with Microsoft OneNote, where this is not my first time experiencing this, which again is actually a bit unfortunate. Like, let's actually use this as an example of how to turn maybe something bad into something good. And like we were talking about in one of the former episodes of, taking any situation that doesn't give you the outcome that you wanted, and instead trying to figure out how this could be beneficial. And one of the things that I constantly do, and I really am like a firm believer of this, is I look at these obstacles, like these failures, like this would be a good one. Clearly, I'm failing to do what I've achieved. But rather than sort of feel embarrassed about that and being angry at Microsoft, one of the things that this reminds me of is this is why Merle and those of us that deeply care about software, this is why we're doing what we're doing. Because Microsoft is like, what, a $3 trillion company, and they can't get the basic syncing. Oh, look, it got that. Okay, that's cool. And it got that. Okay, I mean, I shouldn't have to go out. But the fact that it took so much work, it's great that we have this now, but this is a reminder of why we're doing what we're doing. It's to not have things like this. that this is something that really matters to me, and I feel like the quality of software has been degrading at such a massive level. And oftentimes the reason for that degradation is in quality, I think, is people just don't care. That I know many people at Microsoft, and many of the senior folks that I know, they're brilliant people that are phenomenal. And having these types of issues with Microsoft OneNote, which is supposedly one of their flagship products, this is sort of unreal. Again, if this were coming from a 5-person startup, I could totally understand. But they sell this for money. In fact, my company, we pay to have this and to have it work, so we can do things like a live share. And so while it's working now, which is great, or at least it appears to be working now, these types of, imagine if this was like in front of a live demo of 10,000 people, and it worked, but it took 10 minutes to get it working, but all I had was the actual 10 minutes. Now my thing could be seen as a total failure, when in fact it's just the software that I'm using. And I think personally, this is my view, I think that's unacceptable. And this is one of the main purposes of Merly, is I deeply, deeply care about software, just like I deeply, deeply care about music and great movies and great role-playing games. But unlike those things, we at Merly, we can do something to make the software better. And that's a big reason why we're doing this. That's also a big reason on why I think we're able to recruit and retain such incredible talent like Urs Muff and Tim Matson and Taylor Dozel and Valentine and many other people that are just phenomenal, because I think that these people too understand that my intentions. By the way, the reason why I created that second page is purely so I could click off the first page, so I could click to the second one and hope that a refresh after I exit and reopen it would initiate new socket connections and then refresh the content. So that was actually the purpose of that. And so now we didn't just learn this, we can use this for visuals, we also learned that there may be a quick fix in the event that it's not syncing. Like, so for example, it should have probably synced what I just wrote, and so it's not doing that. Let's try this little fix. So we click here, and then we click back here, and I can see that it looks like it started to draw that. And are you going to do it? It's supposed to do this. I can't control the sync period. I can set it to like do it faster, whatever that means. But there's also a sync button I can press, and I've done that a few times, and that in theory will force the update to happen. Send to MP system. We're going to get this just simple example of, this is like novel. It's like novel IR data sent to some NP system, and this will have some this will be some training or inference output. Okay, I'm just coming up with a very simple visual diagram of possibly one of the most basic machine programming systems that you might try to build. Okay, so let's try this again. Nice, testing. Let me click on this. Oh, look at that. Okay, cool. It's like slowly getting there. But to finish this line of thought, this is one of the key reasons why we're doing Merly, and I think it's also one of the reasons why we're able to recruit such incredible talent, because I think that the folks that are truly missionaries, I think they see that I also am a missionary. Otherwise, I wouldn't be doing machine programming podcasts until two, sorry, that's an exaggeration. Try to avoid hyperbole. Until 1:37 a.m. Friday morning. Like, it's just deep, deep care that helps me do these things. And then for me to continue to find solutions to the different mechanisms for communication. Oh, there we go. Okay, cool. So yeah, we sort of kind of got it. There's probably a way to change there's a way to change the screen size here with the view, I think. Yeah, so I can decrease this zoom. And now I can go back again and show this. Okay, and I don't know if I can move this, but as we get further down, this thing will... Oh, I guess we can just get rid of this, yeah. I don't know that we actually need that, since I'm just doing it all in tablet. So this is our first example of being able to do the visuals. So now we have the spoken, we have the written, and now we have the visuals, so we can hack on a whole bunch of things. That we'll be able to use slides, I'll be able to draw pictures, and as we get into higher order concepts, like how to build a machine programming system, and maybe one of the simplest ways to do it, an MP system that relates to code, is to maybe do what I've just described here. By the way, this is completely ad hoc. I haven't really said anything about anything for this machine programming system, but you could do something like this for machine programming. So step one is you have code. That's what it's attempting to show here, is you're going to have some code, and it's going to process this code and then turn it into some intermediate representation. That's what IR stands for, intermediate representation. This could be something like abstract syntax tree, which, by the way, in general is a terrible idea for machine programming systems that are trying to reason about semantics. And the reason for that is abstract syntax trees generally just focus on syntax, and the abstract part is, I don't know, there's better ways. We can go down this rabbit hole in a subsequent episode, but abstract syntax trees were really good for compilers over the last 50 years, and they're fantastic for that. But for many of the advanced machine programming systems where we're going to start to reason about semantics or intention, we probably want something that captures more information that's semantic or intentional in nature. So that aside, you take the code, you transform it to an IR. Part of the reason why you transform it into an IR is IRs minimally will be, at least all the IRs that I work with, is they will have some sort of graph representation. They may be a tree, so many intermediate representations are trees, but they don't necessarily have to be. You can have things like the contextual flow graph from the neural code comprehension paper, I think, about 10 years ago, which is quite cool. And that is not a tree. It actually has back edges that loop back and create cycles, and trees don't have these things. Trees follow this kind of structure. Is they start at some level, they progressively move down, and either they have the same number of nodes, they either have 0 or n nodes, and they tend to be, I don't know if this is a universal thing, they tend to be sort of like unidirectional. that I think the bidirectional edges is one of the things that moves them away from being a tree into being just sort of some graph. So graph is the superset of IRs. Yes, right, because you can have graphs even with nodes that aren't connected. Let me just show an example. I had a sneaking suspicion I might go a little bit down this rabbit hole. But this is kind of like a good rabbit hole to go down. Because this will help us understand some of the more advanced, maybe intermediate representations. So this could be something like, and I apologize ahead of time for my handwriting. Most of my students really have a hard time reading my handwriting. I'm not like proud of this. I had like failed penmanship and stuff when I was younger, and I never really. Yeah, look at this. See, we're learning all these hacks. Okay, so this is. Oh, whoops! I need to. Yeah, this is actually a representation of something that is I would consider this to be a graph, but we'll add another back edge just to make it more clear. Let's see if it updates it over here with that. I think maybe I gotta press my button here. There we go. Okay. There we go. Okay, so now I have the back edge. So this here could be a tree, assuming that these nodes are connecting downward through these edges, and they're unidirectional. This is not a tree for a few different reasons. First, trees should be essentially every node has to be connected. There's no free-floating nodes, so these are nodes that are free-floating, so this doesn't quite fit that. And then also you can't have these bidirectional edges where an edge goes back and creates a cycle. So again, maybe yeah, I feel like there's specific words and acronyms in this space. Hey, buddy, come down. Words and acronyms in this space that are slipping my mind, but one of them is like a DAG, and I forget what the D stands for, but the A and G are acyclic graphs. Yeah, directed acyclic graphs. So basically, it's something where you don't have any cycles, but it's still a graph, and so this would not even be a DAG because this is a cycle. And there are very important mathematical guarantees that you can begin to provide when you elide away cycles. You can reason about things oftentimes more clearly when there are no cycles, but cycles can also oftentimes help you do a deeper analysis of things. So it's science again, right? There are these trade-offs. So the higher order takeaway here, though, is when you get to step 2, the point is you want to change code into some graphical structure, some structure in computer science that either exists or we invent. And the reason why we want to do that is then we can ensure that we are walking all of the code and we have some degree of confidence for exhaustiveness. Right? There are these two things that we tend to talk about when we talk about mathematical theory or computer science theory, and those things are soundness and completeness. Something that is sound is essentially shown to be logical, that it is correct from a perspective of logic, reason, analysis, something of that nature. However, things that are sound, by just soundness alone, don't say anything about completeness. So, for example, you could have, let's say, an if statement inside of this function, and say this if statement is logically sound, like it's doing the right thing, but it doesn't say anything about the rest of the function. And so oftentimes the second property that you want is completeness, that you show that this algorithm or this equation is sound and complete. So it's really, I think it can be four things. It can be sound and complete. It can be sound and incomplete. It can be unsound and complete, or it can be unsound and incomplete. So the fourth case is kind of, you don't really ever want to be there, because I don't know that you're really adding much if it isn't sound and it isn't complete. But the other three all have value. The one that obviously is like the golden prize is the one where it's both sound, it has soundness and it has completeness. But usually for really hard problems, you generally can't have both. And I'm not saying that you can't ever, but again, science, trade-offs. So yeah, we can, maybe you can get like a nines problem, turn it to a nines problem. And by the way, the nines problem piece is really this thing. Let's see if I can get this thing to update again. Okay. Yeah. So when we talk about nines problems, we tend to say that this is going to be like 99% correct or reliable or redundant or whatever. It'll provide these guarantees. And then the question is, how many nines do we get? And the nines that we're talking about are the nines after the 99%. So when you say it's a 5 nines solution, we're talking about 5 nines after the 99%, or at least that's my understanding. I might be making that up, but at least when I refer to it, is like this would be a 3 nines problem. So we're providing a certain level of quality under whatever domain that we're aiming for with the nines solution. Maybe what we're saying is it's 3 nines completeness for code or something, which basically means we're not going to guarantee that this works for all code, but 99.999% of the code we cover, something to that degree. Anyway, so now we go back to this step 2 on extracting the IR. The key thing is that we want to turn it into a graphical representation, because graphical representation will minimally show us what it looks like in terms of us walking the code for completeness. So as long as we walk each one of these nodes, we can say things like we've done an exhaustive analysis of all the code. Now, it doesn't mean that what we've done is sound. It also doesn't mean that we've walked all the nodes with all these various different states, but it does mean that we've looked at all the code. This can be super important, because if you're just trying to keep track of the code yourself by like walking the lines of code, and then you start getting into these really deep branches, you can lose your place really fast. Whereas if you turn it into an IR, you can mark each one of these as like checked, checked, checked. And then after you think you've checked all of them, you can walk the whole thing one more time, make sure all those flags are set to checked, and say, okay, I'm good. This also can be really important when you're working with an IR and you're going to do rewriting of code. You're going to move things around, and so then you may need to check things again after you've moved things to make sure, like contextually, they still make sense. So usually one of the next steps in these MP systems after you have the code is to transform them into some sort of intermediate representation. And this is the piece that I think a lot of people that are doing machine programming systems today don't quite get right, or they don't deeply understand this, or even have an idea of what this might look like. Instead, they have code and it goes directly to a machine programming system, which is also something that they didn't build. And then it's just simply code to output. And I personally find this very boring because without understanding these steps, understanding what the representation of the code what will actually look like, what semantic or intentional or syntactic information is actually present in the IR. Without knowing those details, I have a hard time knowing the value of that MP system. It's very hard for me to reason about. The second is that with something that's like pre-built MP system, specifically like if it's just a language model, this is often not going to be sufficient for doing more advanced logic solvers or formal reasoners. And oftentimes what you will find is there's a direct correlation between the novel intermediate representation data that's coming in, that's a transformed version of their code, and the MP system that is being trained or inferred on. And so you kind of need a deep understanding of these two things in tandem. It's sort of like imagine if you tried to use the Java runtime environment for C#. Like that is probably not going to work. It doesn't quite make sense, right? My speculation is that the Java runtime system is probably very specific for Java bytecode. And while I think C# was sort of inspired by Java, I think that C# has a number of differences. On top of that, C# I think runs using the .NET runtime environment, which is probably not an identical replication of the Java runtime environment. So if you mix and match here, it's probably not going to work. The same is likely to happen here, is that these things, it may take this input into this MP system and it may produce something that like appears to be meaningful, but if you don't have really deep and thorough understanding of both of these pieces, I think that you are probably going to be significantly subpar for what you could be if you deeply understood this piece and this piece. And then on top of that, there's systems level things, but hopefully this gets a little bit into the 4 domains of machine programming. So just to rehash those one more time so we're all on the same page, is it's really ML, software engineering. Okay, yeah. Now let's try to share this again. Cool. By the way, we haven't really written code, but we are doing some stuff with our diagrams, which I think is awesome. I'm super. This is why I wanted to have this. Yeah. So the 4 domains of machine programming: machine learning, software engineering, programming languages, and systems. Okay, those are the 4. So going back to this, in this case, the code here, this is the PL side. By the way, this is not hitting into the software engineering aspect necessarily. That's a little bit different than just code. Then when you do extracting the IR, that's also a PL problem. So code in raw code form, extraction into intermediate representation, still PL, because you're principally just dealing with code. Then taking the IR and then sending this to an MP system, now this is machine learning. So what we've done here is only really hitting these two domains. We haven't really done anything with systems, and we haven't really done anything with software engineering. Now, the systems piece will come in as we're building the system to then make sure that we can build a highly scalable analyzer that will read in and do things with this code, as well as the construction of the IR. If you don't have strong understanding of systems and you can do this translation, but you do it in 5 orders of magnitude slower than it should be done, then your system's probably not going to get too much traction. That's my strong conviction. So systems comes in when you actually are trying to build these systems, and you need to be able to understand full computer systems. And usually the full computer systems relates to what I call CDC. And this is compute, data, and communication. And I'm really going down a rabbit hole here, but once I start talking, right? Okay, so what we're talking about with systems is usually it's the CDC, compute, data, communication. Compute can be anything that does compute. CPU, FPGA, GPU, ASIC, all those things. And I know I just did a whole bunch of acronyms, but yeah. Okay, central processing unit, which is a field programmable gate array, graphics processing unit, ASIC, application specific integrated circuit, and other stuff. Okay, so that's what this compute part is, and then the data is anything in the data hierarchy that you might find in like a von Neumann computing device. This is not just the data that is seen as a data set that's in a file. It's also things like partial reading the data set, pulling it into the volatile memory of the machine, so things like RAM, but also then as it moves through the hierarchies that are closer than main memory, things like cache lines and registers. Again, if you want to build the systems that are going to be blazing fast, that people are going to be able to use at scale, having strong understanding of the data aspects and how that will function in modern day computers is critical. The last piece is the communication. This is essentially how you're going to communicate for like a multi-node machine learning system, or transferring gigabytes, terabytes, petabytes of data that needs to go from one machine to another for training or for inference, all the things that you might run into when you deal with problems on the edge. There's just a whole bunch of stuff. Okay, so this whole ramble is, I was mentioning that we've got the PL side, we have a little bit of the ML side here, and then systems is basically all the details, the gory details that are required to take this stuff and make it function in a way that it's actually usable, kind of like in the real world. And I understand that this is like a lot of things. And I also realize that not everybody is an expert in all of these things, and it will take time. What I'm trying to do is just give you a more exhaustive, more complete sense of the core challenges that you probably want to be aware of in order to build really robust systems. These are the core things that we think about when we're building our machine programming systems. So part of the reason why Mentor can do millions of lines of code analysis per minute on commodity hardware is we have understanding of the programming languages, machine learning, software engineering, and very deep and nuanced understanding of how to build these things for systems that, like for example, if you try to code all of this in Python, while the system may be correct due to the lack of scalability for Python programs, you may not have something that can gain wide adoption. Yeah. Okay, cool. So I think we're done tonight. I think we achieved all that we wanted to achieve, and the dog stayed with me the whole time. He almost bailed, but I was able to trap him. And then we got to see the visual stuff. And other thing I like too is, we talk about this never stop growing, never stop learning. I thought my day of learning was over because I learned how to do this, and then it broke on us. And so we learned a new hack to do the refresh, which is awesome because now we don't have to throw OneNote away. By the way, I'm going to leave that whole section of me not being able to do this in here because, again, I want to have all of you see me fail, because I think that this will really drive home the point that I've been trying to make, which is, even for someone like me that's supposed to be an expert in all these things, I run into these failures constantly. And a big reason why is I'm constantly pushing the boundaries. Like, I'm not satisfied. I wasn't satisfied with what I could do before. I was like, no, I need to be able to draw pictures. This is critical. And so I'm stepping out of my comfort zone, and then things will break because I'm doing something I've never done before. And that's totally normal. That's actually a really good sign. It shows that you are pushing your boundaries. So see me do it and see me fail, and then see me just say, oh, I'm not gonna be derailed by this. I'm not gonna let the fact that this is being recorded have me become flustered emotionally or panic. Instead, no, we're gonna remain calm and logical, rational, work through this, try to click through a bunch of different things, and then turn this potential bad thing into a good thing, right? It's a good example of why we're doing Merly, is we need better software. We need to help developers have higher quality in the errors that they run into, in the code that they're writing, in the scalability of the systems, in the reduced surface area for attacks. We need these things, and I think machine programming systems can get us there. I think that with the machine programming revolution and a deep understanding of these 4 domains, we can easily 1,000x both our productivity as developers. And I'm not talking about like getting rid of developers. I'm talking about letting the machines handle stuff like whatever the syncing error is for OneNote. Like, the system can self-diagnose and then go in and patch that code. Because clearly the humans are not doing that, right? Like, OneNote's been around for a while. How is that still a bug? And so it's really just sort of using the machines to help us get to our destinations faster. Think of them as they're airplanes that now, instead of having to take boats to travel between continents, you can take an airplane. And so it won't take months of time. You can do it in just a few hours. And that's really, I think, the key with the machine programming stuff that we're building at Merly. And the way I try to teach this at the university is that the human innovation and ingenuity, I think, I don't know if that's ever going to go away or ever not be needed. But I do think there's a reason why we have cruise control in our automobiles. When it's easy and simple and it's just very mechanical, just put it on autopilot for a little bit, and we can focus on the hard things. Yeah. Okay. It's 2:05 a.m., at least my time, and I think we're going to call it a day. Thanks, everybody. I'm glad that we showed consistency and got through one more.